Hi friends, in this video we can learn about Cisc design architecture of CPU. Okay, so basically we have two types of designs for the architecture of CPU. One is Cisc and other is RISC. Okay, Cisc is called, Cisc is, the full form of Cisc is Complex Instruction Set Computer, whereas RISC is Reduced Instruction Set Computer. In this video we are going to see what are the characteristics of Cisc, and the later video we will see what are the features of RISC. Okay. Now whenever we come to Cisc here, it says Complex Instruction Set Computer. That means here we use or we embed many micro operations or micro instructions into one instruction and we execute it. That means we execute one instruction in which we have multiple number of small instructions. Okay. Now here I have wrote down the characteristics of the Cisc. Okay. We'll see one after the other. First one is minimize number of instructions per program at a cost of instruction cycle. We have instruction cycle and clock cycle, right? Okay. Instruction cycle is given by number of instructions or number of cycles is taken for instruction. Okay. Now here it says that minimize number of instructions per program at a cost of instruction cycle. Okay, that means whether if we increase the instruction cycle of the program, but we will decrease the number of instructions per program. That means time taken for the program might be more, might be less. Okay, but number of instructions per program should be decreased. The next thing is decrease the memory cost. If I am using multiple small instructions under one instruction, then definitely my number of instructions will be more. But as I am considering only one instruction set and under that I have multiple instructions, my memory for the program will be less. Okay, so we will decrease that memory cost in the program. Okay, this is the Cisc architecture given. It has microprogram control memory and control unit, instruction and data path, cache memory and main memory. Okay, now here we have, this is mainly called software part because here we use one operand is used from the register and another operand is used from memory. Mostly we use memory here rather than other registers for operations. Okay, so between the programmer and the hardware, the only mediator is instruction set architecture. Okay, this instruction set architecture is the mediator between programmer and hardware. Okay, it is like this instruction set architecture has two parts, opcode and operand. This opcode is instruction applied to load and store micro operations. If you apply any instructions to load and store operations, it is shown under opcode, and operand is the memory register which we apply instructions for operations. Okay. Now next is addressing modes. What is addressing mode is, it says that, or it defines the manner to access the data, in which manner the data should be accessed. That means indirect mode or direct mode or index addressing mode. Okay, depending upon the processor we use. Okay. Now the main important part is CPU performance. When we compare Cisc and RISC, the important factor that plays a major role is CPU performance. CPU performance is given by seconds per program. That means the program which is to be executed in how much time? That is seconds, right? In how many seconds my program is executed. So in that I can divide it into three parts, like I can multiply and divide by instruction, I can multiply and divide by cycles. So I get instruction per program, cycle per instruction, seconds per cycle. The first one is number of instructions under a program, that is instruction count. Okay. The second one is number of cycles it's taking per instruction, that is instruction cycle. Number of seconds it's taking for cycle, it's called clock cycle time. Okay. Now, as I discussed earlier, the instruction cycle, at the cost of instruction cycle, we will minimize the instructions, number of instructions. We will minimize this, and even though it is more or less. Okay, that is the main aim of Cisc type design of architecture of CPU. Okay. The next thing are examples of Cisc. Okay. These are Intel 80486 processors. It is also a 32-bit processor. Okay, where the instruction length is from 1 to 11. It uses 1 to 11 bits and have 235 instructions which are variable. This is the main theme of Cisc here, and the main differentiator between Cisc and RISC. Here we use the variable instructions, not the fixed length. Variable length instructions. Okay, the length of the instruction might be varied according to the need. That means here we can use 2 bytes, 4 bytes instruction, or 8 byte instruction, or 6 byte instruction the last. Okay, here we can use only 6 byte instruction the last. Whereas in RISC we use only fixed type of instruction. That means if it is 2 bytes, or it is 4 bytes. Okay, I'll say why we use fixed type of instructions in RISC in the later videos. Okay, and other processor is IBM 370 by 168. It is also 32-bit processor. It has 4 into 64-bit float point registers along with this 32-bit processor. Okay, next, the main characteristics of Cisc are instruction decoding is complex. Why instruction decoding is complex? Because here under one main instruction I have multiple instructions. So decoding the third instruction or second instruction from the main instruction is little complex for us to decode. Okay, to get the decoding mode. Less chip space is enough because we use memory and register. Where memory and register operations we use, so we don't need much space on the chip, right? Okay. Next is one instruction is enough to support multiple addressing modes. Here the main part is we use multiple addressing mode and multiple instruction formats. Here in Cisc architecture, we use multiple addressing modes under one instruction. Okay, that means the instruction mode, if under one instruction there might be, suppose there are 4 instructions, one can be index addressing, one can be indirect addressing, one can be direct addressing, and other can be register mode addressing. It can be any type of addressing modes, but we'll use all these modes under one instruction. The next thing is mul is the complex instruction which is used here. This mul has 3 instructions under it. Okay, mul is categorized into 3 blocks. These are load, product, and stored. Okay, load, product, and store. Here load is used for retrieving the data from memory to register. Load is for memory to register. Okay, whereas product is, it sees the operand from the register and other operand from the memory and product it and do the product operation. Okay, product operation here. Store, whereas store is sending back the data from register to memory. Okay, this is the complex instruction which we use under mul. Okay, so this is the one of the example. This is my one instruction under which I am performing 3 different instructions. Okay, so this is all about Cisc type of architecture of a CPU. In the next video we will see what is the RISC type of architecture. That's all for this video. Thank you.